Sir.
Okay, so yesterday what we did, I just gave you a brief idea about the subject, and then after I gave you the formula sheet, and then after we discuss about the relationship between the derivative and the antiderivative. I told you antiderivative means integration is a first process of derivative. I gave you the example too, and then after we went over few of the figures, rectangles, squares, above x-axis, below x-axis, then triangle, circle like this, and try to figure it out the areas, because I told you integration provides you an area of the given curve, uh, given curve, and bounded by some x y axis, something like that. So, and then after we just started the Riemann sum. So Riemann sum, that is the article 5.3. So there are three types of ancient people. They were using this method, that left hand rule, right hand rule, midpoint rule, which provides you the approximate answer. I mean to say approximate area, but not the complete answer. But this approximate area is very, very, very close to your complete answer. And Riemann introduced the integration after this one, which provides us the exact area of a given curve bounded by some axis. Okay, so we went over this one. I told you that left hand rule, that means your curve is, or strip is intersecting the curve at most left part. Most left starts from here. And right hand rule means your strip or your uh, rectangles, I would say, or partitions intersect your curve on the most right side. Midpoint means it is on the middle of the part. So we went over this example, 4x minus x squared. We have been using this example so many times in this chapter. So at least you will have some idea how the method or methods are different for what is the difference between the different methods. That's what we can figure it out over here. As I told you, left hand rule, that means we are going to find f of 0, because 0 to 4 and n equal to 4 means 4 partitions. So 1, 2, 3 and 4 partitions are there. F of 0, 0 equal to f of 0, that is my most left part. And then after my strip intersects the curvature over here on the left side is f1. You have to draw your picture accordingly. Here it is. Then if you can go like this, and this is here. So f of 2, f of 3, like this. And we don't count the last point for left hand rule, and vice versa for right hand rule. You need to draw your pictures a little bit different like this. Look at over here, because it has to be on most right part. So f of, we don't count the first point, we start counting the first, second up to the nth point, last point. So f of 1 equal to f1 to f1, 2 to f2, 3 to f3, but my figure will look like this one. Look at here. Here almost every part that was inside the figure. Here every part almost that is outside the figure, and then after it goes like this. So here it is, 1 and f of 1. Then I would like to go over here, because right part is this one. Then after right part over 3 is f of 3 over here intersecting the curvature, and f of 4. And then after I say that, sum up or add up all these things, f of 0 at and multiplied by 1, because now you have a rectangle. Strip means rectangles, and rectangles area is the thing but length into breadth. So that's what I'm doing over here, length into breadth, and summation. And then after we did the same thing for the midpoint rule. So midpoint rule, now my figure will be slightly different, because my midpoint of 0 and 1 is 0.5, 1.5, 2.5 and 3.5. That means my strip must intersect the curvature at these points. Look at over here, 0.5 and here. So my strip or my rectangle must intersect the curvature at the midpoint. So 0.5, and the intersection part is f of 0.5 is 1.75, because we are plugging this value in our function for x minus x squared. Same here, 1.5, so 1.5. And so it goes like this. Then after we go like this and try to figure it out midpoint over here. And then after, because your make sure that you have to start like this, your midpoint between FF1, that means you have to stop over here. Then take one more line over here and then go like this so that you can find your midpoint over here. Then again, your midpoint over here and like this. Right? This is actually F of 2.5. So to slightly wrong picture, but I think you can figure it out. So like this. And then after I just sum up all these things and I'm getting almost same area. And then after yesterday I told you to remember or to go through the summation notations. Summation of AI equal to A1 plus A2 plus A3 plus A4 up to AN, because if you replace I by different numbers, I by 1, then 2, because I runs from 1 to n. So 1, 2, 3, 4, 5 up to n, and summation means addition. So you can see over here, I is the index of the summation and AI is the ith term of the summation. Ith means first term, A1 means first term, A2 means second term, A3 means third term, AN means nth term, right? So 1, that is the lower bound of the sum, and n is the upper bound of the sum. So this 1 and n, lower bound and upper bound of the sum. There are some specific rules. This AI, there's a general formula, but suppose AI equal to I, and summation I equal to 1 to 6 and I. So I equal to 1, 2, 3, 1 plus 2 plus 3 plus 4 plus 5 plus 6. 6 means you would stop over here because that's your upper bound. And then summation is 21. I plus 1, replace, you have to start now I with 0. So 0, 1, 2, 3, 4, 5. But plus 1 is there, 0 plus 1. So this is the summation. J square. So whatever the values you have, j equal to 3, 4, 5, 6, 7, you have to first square and then sum. And then after, whenever you have some constant, you can always pull your constant out of the summation sign. And summation is linear in addition and subtraction. AI plus BI, summation of AI plus or minus summation of BI, right? Like this, suppose summation of I plus I square, something like this. So summation of I plus summation of I square, you can separate out and then you can add them up. Okay, now the most important thing is summation formula. Summation of some constant term, because here there is no I inside the summation sign. Please pay attention, guys. Please pay attention. Here there is no I. So I equal to 1, 2, 3 up to n. If I take I equal to 1, but there is no I, how can I take I equal to 1? So for I equal to 1, my value will remain the same, C, right? Then or I can pull the C out and here it is 1. So for I equal to 1, it is constant. So it has to remain the same. It is 1. I equal to 2, again it is 1. I equal to 3, again it is 1. How many times? I equal to n. So n times it is 1. So 1 plus 1 plus 1 up to n times. N times like this. Means 1 plus 1 n times it is n C times n or n times C. Then you have to memorize some of the formulas. Of course, proofs are there, but we omit this one. Summation of I equal to 1 to n. I, that is given by n into n plus 1 by 2. Suppose I have I equal to 1 to 5 and I. So it is 5, 6 divided by 2. 6 divided by 2 is 3. 5 multiplied by 3 is 15. So summation I equal to 1 to 5 of I is 15, like this. Then summation of I square, n into n plus 1 to n plus 1 by 6. All these formulae are there in the formula sheet, but some of the things I think we should memorize just to save our time. Summation of I cube is n square n plus 1 whole square divided by 4. Okay, now example. So we did up to here. This is just the revision portion of this 10-12 minutes. And now we proceed further. So approximate, again the same function. See, intentionally I am taking the same function so that you can figure it out, the differences. Here approximate a equal to 0 to b, a equal to 0 and b equal to 4. Or you can say 0 to 4. 4x minus x square dx using right-hand rule and summation formula with 16 equally spaced subintervals. 16 equally spaced subintervals, that means now he is asking us to consider 16 partitions. Means your n equal to 16. That means it will look like this one. Just let me show it to you. Just wait. will look like this one. Look at here, guys. It will look like this one. So please keep in mind this thing, that number of partitions, if you increase number of partitions, that means you are getting more and more approximate or good approximation, more and more approximate value, more good approximate value. So increasing of partition will let you go towards the exact answer. So please keep this thing in mind. Okay, so one example, but I want to use this example for now. We are going to use that summation method with n equal to 16 partition. And then after, I'm going to consider the same example for general n. Whenever we have general n, means now in that case, n could be anything. Anything, I mean to say that n could be 100, n could be 1,000, n could be million strips in your region. So you are increasing your partitions, means you are getting more and better approximation, right? So please keep in mind this thing. So first I took 4 partitions. Now I'm increasing my partitions just to make sure what the answer I'm going to get. So look at over here, when using left hand rule, height of ith rectangle. Okay, that's fine. Now one more thing. That's what you have to memorize, because you won't find this thing in the exam, in the formula sheet. So left hand rule. Whenever you find you are using left hand rule, height of ith particle, ith rectangle. So first rectangle, second rectangle, that is given by f of xi, because we are starting from most left part, in 0 to 4. So we counted 0. So f of xi, if x1 is 0, we are counting f of 0. That's why it starts with f of xy. But in right hand rule, ith rectangle is f of xi plus 1, because it is not now this point, this is over here, xi plus 1. John, are you paying attention? John, okay. So f of xi plus 1, right? That is the formula. So please, you won't find this formula probably in the formula sheet. So please memorize this thing. And for midpoint rule, I'm going to write ith rectangle is f of xi plus 1 divided by 2. So whenever you are working with this one, what I would suggest, first try to figure it out, your xi plus 1 divided by 2. This part, and then apply your function. And your interval a to b, whatever the integration interval a to b is given to you, this interval, the length of all this partition, what is the width of the partition, that can be obtained using this formula. Please pay attention. Delta x equal to b minus a over n. B is here, b is your 4, because 4 rectangles were there, right? So 4 minus 0 and n equal to number of partitions. 4 is the upper bound. 0 is the lower bound. 0 is this one and 4 is this one. So your x runs from 0 to 4. Between 0 to 4, we are dividing our interval into 16 parts. So n equal to 16. So 4 divided by 16 means 1/4. Means width of each of this particle is 1/4. So it see width of each of this particle. Let me write it down for you. So 1/4, 2/4, 3/4, and 4/4 is 1. Then 1, 2, 3, 4, right? 3/4, 4/4. Then 5/4, 6/4, 7/4, and 2. 8/4. Then 9/4, 10/4, 11/4, and 12/4 is 13. Then 14/4, 15/4, 14/4, 15, and 12, 9, 10, 11, 12. Then 13/4, 14/4, 15/4, and 16/4 is 4. It will look like this one. Look at here, guys. All you guys agree with me?
Yes, sir.
Yes, sir.
Okay. Good, guys. Now delta x equal to b minus a divided by n. B minus a divided by n. B is your 4 and a is your 0. A is your 0. So 4 minus 0, n equal to 16, 4 by 16 equal to 1/4. And that's why I got length of or width of each particle is 1, or each partition is 1/4. Right? Now, look at here, guys. This xi, but I told you that how can you fix this xi for general terms or xi plus 1? There are specific formulae for xi and xi plus 1. These articles requires little bit more attention, guys. Otherwise, other articles are okay, but this article requires little bit more attention. So if you want to have some stimulator tea, coffee with you, I don't mind, right? But please let me know so that I can give you a break of 5 minutes and you can have something. Okay, whenever you want something, please let me know. Okay, guys, but please pay your full attention. Otherwise, if you read the book, probably you will not get the complete things. So make sure that you are getting complete things what I would like to convey to you. So xi is given by, see, xi that is equal to a plus I minus 1 and delta x. So once you fix your delta x, this is my delta x. Delta x is this one. And xi equal to a plus I minus 1. A is nothing but your first term. A, or you can say x1, x2, x3 like this. Now, I made this partition like this. Look at over here. 0, 1 by 4, 2 by 4, 3 by 4, 4 by 4 is 1 like this. I would like to give the name. So I can start with x1. So my first one is x1, x2, x3, x4, x5, x6, x7, x8, x8, x9, right? x10, x11, x12, x11, x12, x13, x14, x15, x16, and finally x17. So I would like to divide like this. Because I started with 0 equal to x1, so I went up to 17th, x17. And that's what I mentioned over here. Look at here. So that is my xi. This is the formula, a plus a, or you can say x1 plus I minus 1 delta x. And xi plus 1, that is a plus I times delta x. Simply I times delta x. Not I plus 1, just I times delta x. Look at here. Right? So please keep this thing in mind. These two and these three formula. F of xi, left hand rule means f of xi delta x. Right hand rule, f of xi plus 1 delta x. Midpoint rule, f of xi plus 1 by 2 delta x. And this xi is measured using this formula, a plus I minus 1 delta x, xi plus 1, a plus I times delta x. I will let you know what we mean by this. This is just the background to start with the example. Okay, so now, first of all, I would like to start with right hand side, right hand rule. You must be wondering that why I did not start with left hand rule and why I want to start with the right hand rule. Am I right? Am I right, Jonah?
Yes, sir.
Good. Girls, are you okay?
Yes, sir.
Are you okay?
Yes, sir.
How many girls are there? Just one?
I had a quick question.
Go
So
ahead.
for
I can't see your picture.
X, huh?
I can't see your picture.
It's up.
It is up. Okay,
Yeah.
go ahead. Go ahead.
So for X sub I, it's a plus I plus delta X, and then
No,
the other one
it is
I
not I
times.
plus, it is I minus 1. I minus 1.
Oh, okay. I didn't see
Not
that.
plus, I minus 1, bracket complete, delta x.
Okay, so that's all multiplied by delta X, so it's okay.
Yes, first of all, I minus 1 and delta x. Look at it. What is your name? I forgot.
Alexis.
Alexis, I'm sorry. Yeah, Alexis Davis. Yeah.
Yes, sir.
So, Alexis, look at over here. I minus 1 x. I minus 1.
Yeah, I
Yeah.
just couldn't read it
And
squared.
delta x, you can, delta x, that is this term, delta x equal
Yeah.
to 1/4 here in this example, right? You can obtain, you can get this delta x from here. Make sense?
Yes, sir. Thank you.
Okay, now let's start the example. Yes, my question is still there. What start with right hand side, right hand rule. Pay attention, guys. Try to look at me. Whenever you want, suppose I ask you that use summation notation, summation formula to find the area. If I say like this, that means I leave it to you. It's your choice whether you want to go for left hand rule or right hand rule or midpoint rule. Always try to attempt right hand rule if somebody gives you the choice, because right hand rule, you can see over here there is no I minus 1, simply I times delta x. So your calculation is much easier than the other parts if you start with right hand rule, but it is up to you. Then after, my second choice would be left hand rule, because it's simply I minus 1 by delta x. That's fine. But here xi, so first I have to go for this xi. I have to fix this one. Then after I have to fix this one too. Then after I have to sum it, I have to divide by 2, and then I can apply the function. So it's almost double work over here. So midpoint I don't prefer unless I'm forced to, or I'm asked to do, I'm asked to use only midpoint. So if I specifically mention in the example that use left hand rule, I'm sorry, but you don't have any other choice. But if I don't mention anything, in that case, choice is yours. And I would personally prefer to choose right hand rule. You are not getting this type of things in the book. Am I right? These things can only be obtained or can only be discussed in person, right? Nobody writes this thing in the book. Yeah. Okay. And that's why so many times I've been repeating this thing that writing a book and teaching both are separate things, both are different. Okay, guys, so my right hand rule, f of xi plus 1 delta x, I runs from 1 to n, my n is 16. So I'm writing like this, I equal to 1 to 16, f of xi plus 1 delta x. Agree? Now, my delta x already I fixed. I fixed this one. So delta x b minus a over n, 4 minus, so 1/4. First, let me fix my xi. Don't look at here. Let me fix my xi. Xi equal to x1 or a plus I minus 1. My a was 0. Agree? You have to be very much familiar with this diagram, this figure. My a equal to 0 or x1. B equal to 4 or x17. Okay? Good. Good. So a equal to 0 or x1, I minus 1. You can't change your I because I runs from 1 to 16. It's a partition. I equal to 1 means it's the first partition, 2, second, third, fourth, up to 16th partition. So don't change it. I minus 1. And delta x is 1/4. Means xi value is I minus 1 divided by 4. Agree? Xi plus 1 is x1 I times delta x, or a plus I times delta x. A is 0, I as it is. I told you don't change your I. Delta x is 1/4. So it is I divided by 4. Agree? I divided by 4. Now guys, look at over here. Look at here. What was my function? My function was fx equal to 4x minus x squared, right? This was my function, fx equal to 4x minus x squared. And what I'm looking for now, look at here. In the formula, I'm looking for f of xi. Means my fx is replaced by xi. Xi is this one. So fx, what was my xi? My xi here is I minus 1 1/4. Agree? That means I have to replace this xi by I minus 1 1/4. So f of I minus 1 divided by 4. That is equal to, look at here, f of I minus 1 divided by 4. Means throughout this function, left and right side, I have to change, I have to replace this x by I minus 1 by 4. See, every time this I minus 1 part is bothering us. Bothering us means we are using left hand rule or right hand rule. Okay, let me find both first. So I minus 1 divided by 4. So it is 4 times I minus 1 minus I minus 1 square divided by 4 square. Am I right? Yeah, I replaced x by I minus 1 by 4. Make sense? All of you?
Yes, sir.
Sir.
Okay.
Yes, sir.
Good. So that is equal to 4 will get cancelled out. I minus 1 minus I minus 1 square divided by 16. I minus 1 square divided by 16. I minus fx equal to I minus 1 square divided by 16. Okay, so that is equal to I minus 1 and minus I minus 1 square divided by 16. That's fine. Okay, that is equal to I minus 1 inside the bracket 1 minus I minus 1 by 16. And that is equal to I minus 1, and here is 16 minus I minus 1 divided by 16. So that is equal to I minus 1 and 15 minus I divided by 16. See, I'm getting something like this. See? Long calculation. But again, this f of x I, that is required for left hand rule. But I'm working with right hand rule. So let me first go for f of xi. This is my f of I minus 1 by 4. That was my I minus 1 by 4. That is my xi, f of xi. But for right hand rule, I want f of xi plus 1. So let me go for now f of xi plus 1. F of xi plus 1 is I by 4. So f of I by 4. F of I by 4. That means, look at here. In this function, x is replaced by simply I by 4. So that is, my work is now way less than the previous work or left hand rule. So f of I minus 4. So 4 times I by 4 minus I by 4 square. Agree? 4 times, look at here, 4 times I minus 4 minus I minus 1 square. So, because it is simply I by 4, so that is equal to I minus I square by 16. I minus I square by 16. So just keep this I minus I square by 16 as it is. See? So you can compare these two expressions, this one with this one. See, this is way awkward than this expression. Way awkward than this expression. So that is the reason I told you to choose right hand rule if you are given the choice. Okay, now let's proceed further. Look at here, guys. So my f of xi plus 1, this is f of x is replaced by xi plus 1, means I by 4. So f of I by 4 is this one. So I fixed in this formula integration 4x minus x square dx. See, that is approximately given by summation of f of xi plus 1 delta x, because previously integration was not defined. And we claim, or Riemann claim, that the summation, whatever you are getting the area using summation formula, should be very much approximated or very much nearer to your exact value, exact area. And this formula says that f of xi plus 1, f of xi plus 1 is f of I by 4, f of I by 4, delta x is 1 by 4. Don't forget this delta x, 1 by 4. F of I by 4, we just counted separately, I minus I square by 16. F of xi, yeah, I minus, oh, okay, I minus I square by 16. Okay, so what I did, I just pulled this 1 by 4 out because it's a constant. So just pull it out. And f of I by 4, that is I minus I square by 16. Plug the value over here. Now, I hope all you guys are good up to this step. Am I right?
Yes, sir.
Yes, sir.
Okay.
Sir.
Now, what we are going to do, summation. You know, I gave you summation notations or some of the properties. Summation of AI minus BI equal to summation of AI minus summation of BI. So I'm going to use that property over here. Summation of AI is summation of I. And second part, summation of I square by 16. But again, 1 over 16 is constant, pull it out. So right now, don't pull it out over here, please. It's just summation, this 1 over 16 that is just over here. So just pull this one out, or just out of this summation sign, not the whole part, please. This 1/4 is out of whole part. So that's why I use the big bracket. Way of writing makes a big difference in mathematics. Sometimes your brackets, your curly brackets, your big brackets, which way you are using makes a big difference. Okay, now summation of I, you know summation of I means I give you the standard formation. Standard formation, summation of I is n into n plus 1 by 2. Agree? N into n plus 1 by 2. Summation of I square is n into n plus 1 to n plus 1 by 2. But what is your n? N is your upper limit. Agree? Upper bound. Just use these two formulae. So summation of I is, I put the circle, that is n into n plus 1 by 2. N is 16. N plus 1 is 16 plus 1, 17 by 2. So by 2. That is my first part. Minus. Now I use the curly bracket. Why? Because my 16 is out. And then summation of I square is n into n plus 1. And 2n plus 1. 2n means 2 times 16, 32 plus 1 is 33 divided by 6. And all are in multiplication. So you can cancel the common things and we are getting something like this. 136 minus 187 by 2. 136 from this one, 17. Here it is 8, right? Outside it is, so 1 by 4th outside, 17 8s are, this is 8. 17 8s are 136. And this 16 and 16 gets cancelled out. That means you are getting 17 multiplied by, here it is 2 3s are 6 and 11 3s are 33. So it is 17 multiplied by 11 divided by 2. So you are getting 187 by 2. If you use your calculator, you're going to get 10.625. Now guys, look at me, all of you. Do you remember for the same formula when I took just 4 partition, not 16, when I took the 4 partition, what was my area? My area was, do you remember? It was just 10.
It was
Yeah, 10.
Yesterday we did
just
this.
10.
Now I increased my partitions and I am getting my area 10.625. Look at here. Again, recall this thing. What was my area for right hand rule and left hand rule? It was 10 and 10 for 4 partitions. Agree?
Yes, sir.
But midpoint rule, I got 11. Do you remember that thing?
Yes, sir.
Please,
Sure.
guys, please work with me. Every day, if I am teaching here for 2 hours, it is your job to work at home for 3 hours. Otherwise, you will be just out of the subject. You will not be on track. So don't blame me, guys, please. And I told you yesterday, don't compare this course with your Calc 1. I think you might have realized this thing in just first 2 days, right? It's not Calc 1. Calc 1 is way, way, way easier than this one, right? Just derivative and application, that's Calc 1. Please pay attention. And without this one, you can't survive because all of you are science and STEM major. So it's really, really difficult for you to survive without this Calc 2 or any Calc portion, Calc 1, 2. Very frequently, you will be using all these things in your field. Yeah, so trust me and pay your full attention because whatever you are going to do nowadays till your graduation, that will pay you, that will help you throughout your life. Yeah. If you want to be a good engineer, in that case, you have to have good command over mathematics. Without mathematics, you will not be a good engineer. Yeah, engineering, that is just the applied mathematics. That's what I say. Yeah, those who are good with mathematics, definitely. If you are very strong at math, means 50 or 60% of engineering field is covered. Then after you have to just create a talent, how to use your math knowledge in your engineering field, in applicable field, applied fields. That's it. Yeah. If you are not good at math, you will not be good in your major. Yeah. That's the fact. I'm not telling you these things because I am a mathematician. No. This is the general thing. Yeah. Anyway, guys, that's not my part. We'll talk about all these things sometimes later, not right now. Okay. But let me finish this example. So I just increased my partition 4 to 16 and I'm getting my area now 10.625. My midpoint rule give me the area 11. Do you remember that thing? It was 11. Left hand rule and right hand rule gave me 10. Now it is 10.625. See, I increased the partition and I am approaching towards 11 now. I don't say 11 is the right number. No. No. I don't say. But
No.
now, you know, my range of answer is decreasing. My range is decreasing. It was 10 to 11 first. Left and right hand rule and then midpoint rule 11. But now it is 10.625 to 11. See, my range reduces. My range reduces. Am I right?
Yes, sir.
Yes, sir. So the
Yes,
more
sir.
Right?
rectangles
That
you
means,
have,
yeah, I am getting
more
more and more better approximation. Are you getting me?
yes, sir.
Sir.
Yes, sir.
Good. Okay, so that is my midpoint rule. Now I will, sorry, my bad. That is my right hand rule. Now I would like to go for left hand rule with the same example. That is the beauty. See, I just took the same. You won't find all these things in my book, please. Book, we took the different examples for different methods. I don't know why, but yes. But here, again, teaching is different than writing a book. Okay, so left hand rule, 4x minus x square is approximated by summation f of xi delta x. F of xi is given by xi plus delta I minus 1. This is I. This is I, please. Alex Davis. Alex is
Yes, sir.
1. This is I. Please make
Yeah,
it.
yeah.
Yeah, I minus 1 delta x. So x1 is your first number, that is 0, plus I minus 1 delta x. Already you figured it out, that is 1/4. So f of x was 4x minus x square. I have to replace this fx by xi. So 4 of xi minus xi square. But xi is I minus 1 by 4. So I minus 1 by 4 and 4 and I minus 1 square by 16. And that's what I did over here. Look at over here. That's what I did over here. Long calculation. Left hand rule. Okay. So I minus 1 as it is and I minus 1 square divided by 16. Just a minus b whole square. That is a square minus 2ab plus b square. I use that formula. So a square minus 2ab plus b square divided by 16. So I square minus 2 times I times 1, 2i plus 1 divided by 16. Okay. Now 16 is my LCM. That's what I did over here. 16 is the LCM. 16 times I minus 1, 16i minus 16 minus I square minus plus. See, these curly brackets now is forcing me to multiply this negative throughout all the expressions. Agree? That is why I told you that which bracket you are using, that is more important in mathematics. Mathematics is a subject of particularity. It will teach you how to be particular in writing each and every step, each and every number, each and every notations. And that will make you particular in your life too, because you know, if you are doing mathematics for a long period of time, in that case, your mind will be habituated to get particularity in all your other works too. So don't think that you are just learning this mathematics. No, on the hidden side or back side of the mind, you are learning a lot of other things which are not known to you, but simultaneously you are doing something. Yes. So think positively. Think positive, you will get all other positive things, right? Anyway, so particularity, that is the main part of the life. Anyway, 16. Now if I solve this one, if I simplify this one, 16i and 2i is 18i, I square as it is, negative 16, negative 1 is negative 17 divided by 16. Now my f of xi is this expression. I am going to use this expression over here in my formula. So always you have to count this one separately before you start counting your left hand rule or right hand rule, whatever it may be. So now I just plug this value f of xi 18I minus I square minus 17 by 16, and delta x was fixed 1 by 4, constant value. I just pulled it out. Now again, summation 116, again it is constant, let me pull it out. So 16 4s are 1, 64 over here outside the summation sign. Summation of 8i, now summation of this, summation of this, summation of this, summation of 8i, 18i. 18 is again constant. So let me pull it out by my summation sign, out of my summation sign. So 18, don't write here, please. I put the big bracket, 18 summation of I. Minus just I square, summation of I square, minus summation of 17, but 17 is constant. Let me pull it out of my summation. 17 and summation of 1. Agree. Again, go back to summation formulae. I gave you 4 formulas, right? Summation of constant C, I runs from 1 to n, that is C times n. Agree? Here your C is 17. So 17 times how n is 16. So 17 times 16, because I equal to 1, 1, 2, 1, 3, 1. How many times? 16 times. Are you getting me, guys?
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Thank you. Yeah, please respond me. Good. So 16 times 17, right? And then after I square is I into I minus 1. N into n minus, n into n plus 1, 2n plus 1 by 6. N plus 1 is 17, 16 plus 1. 2n plus 1, 16 to the 32 plus 1, 33. Divided I. Ooh, let me charge my computer. Wait. Okay. I'm all right. Okay, and then summation I, n into n plus 1 by 2, n is 16, n plus 1, 17 by 2, right? So 16, 18, 17, 16, 18 by 2, this is blah, blah, blah. Just simplify this one, use your calculator. You are going to get 10.625. Look at here, guys. Left-hand rule also gives us 10.625. Right-hand rule also gives us 10.625, right? Means answer is whatever we got yesterday, 10 and 10, that was not the correct answer. It was nearer to 10, but not the correct one. This is more appropriate than the previous one because I increased my strips, I increased my rectangles, right?
Yes, sir.
Yes, sir.
Now I would like to check my midpoint rule using the same thing, same example. See, if you use the same example and try to apply different rules, you will come to know the differences. Right.
Excuse me, sir. For the solving for x of I, over on the right side of your notes, from the third, when you go from I minus 1 minus in brackets I squared minus 2I plus 1 over 16 and all the way to straight down to 16I, how did you get there right there from that step down to the next step?
I know, here to here, right?
Yes, sir. I understand the rest. I just don't understand right there that
Yeah.
exact point.
Your pre-calculus, look at over here. A minus B divided by C. It is something like this, am I right?
Yes, sir.
A minus B divided by 6, right? Your A is I minus 1, your A is I minus 1, B is this one, and divided by C. Agree?
Yes, sir.
What is LCM here? Least common multiplier or least common divisor?
16.
No, oh yeah, 16 or C here, right?
Yes.
C.
Yes.
So how can I, yeah, it is least common divisor. So what I'm going to do, least common divisor, that means I have to multiply throughout by this least common divisor. So multiply C, A minus B divided by C, like this.
Okay, yes, sir.
Okay, now open the bracket. So you are going to get A times C minus B, C and C will get cancelled out. Okay?
Yeah. Okay, yes, sir.
Yes, you are going to get A times C minus B. Agree?
Yes, sir. I see
What
that.
was your A? I minus 1. Agree?
Yes, sir.
I minus 1. That was your A. What was your C? 16. So 16 times I minus 1. Am I right?
Yes, sir.
Read over here. 16 times I minus 1. 16
Oh,
minus
okay.
16. Minus,
This is-
look at here, John. This is my B. My B as it is.
Mhm.
Whole divided by C. AC minus BC. Yeah, and whole divided by C. Right?
Perfect.
So
Perfect.
that's
I
how
got it.
you can go for the LCM. That's how you can go for. So I just divide N and multiply it by C. That's how we can work on this one. Divide N and multiply it by C. So that is the LCM. That is called LCM. Dividing and multiplying by C.
Thank you, sir.
That is LCM, right? Least
Yes,
common
sir.
multiplier, least common divisor. Anyway, guys, let's start with midpoint rule. So midpoint rule says that fx minus x square dx and f of xi plus 1 by 2 delta x, right? Delta x. Okay. So now delta x is b minus a over n, that is 1/4 common thing. Xi, we figure it out, I minus 1 by 4. Agree? Yes or no?
Sir. Yes, sir.
Yes,
In my first example, xi was, look at here, xi, I minus 1 by 4. Xi plus 1, I just use the same formula, but I don't want to repeat the same things, right? I use the formula x a plus I minus 1 delta x, a plus I delta x. So xi is I minus 1 by 4. Xi plus 1 is I by 4. So I use the same thing over here. Xi is I minus 1 by 4. Xi plus 1 is I by 4. I am looking for xi plus 1 by 2. By 2. So I minus 1 by 4, I by 4 divided by 2. Agree? Simplify this one. John, now my LCM is 4. Common. Right? LCM is 4.
Yes, sir.
Right? See, one more thing. Stop here. I just told you, I just explained to you that LCM, A minus A by C over here, right? The better approach is like this. Let me explain to you again. A minus B divided by C. I want, John, look at here and all of you. I want the common denominator. Common denominator. How can I get the common denominator? I can get common denominator only if I divide and multiply my first number A by C. So divide and multiply it by C. So A times C divided by C minus B over C. Shall I write like this? Yes or no?
Yes, I see that. Yes.
Right? So that will provide us AC minus B divided by C. Here, simple. Agree?
Yes, sir.
So that's how you can take the LCM. I'm trying to buy Wacom so that if you have some doubt, I can write it down over here on the screen. I'm over here on Wacom, and you can look at here on the screen. Okay. So maybe I will go to Home Depot, or no, not Home Depot, but what?
Best Buy.
Best Buy. Best Buy today. Because everything was closed till 15th, but probably they have opened now. So I don't know, they have opened probably, I don't know. But otherwise I have to, but I'll make sure, okay? Very soon I will buy Wacom or tablet, something like this, so that I can write and you can look at over here.
Sir, can you send us the rating that you send in red that you're showing up on the screen? Can you send us photos of that or email it to us on Canvas?
I can send it to you, but
Perfect.
I don't know how can I send it to you.
Just take photos on your phone and then just email it to us.
But email to all of you, I think let's do one thing, John. After this class, just stay with me, John. John.
I'm here.
Yes, just stay with me. After all other guys are signed out, then just stay with me. I will provide you my cell phone number.
Yes, sir.
Right, and I will take the picture and send it to you. And
yes,
please
sir.
do this favor, send this one to all our classmates.
Yes, sir.
That's good.
Yes, sir.
So please do this favor to me. I will provide you because I don't want to give my cell phone to everyone. You know,
Yes, sir.
you can understand, right?
Understood.
Yeah. So I will give you just one guy, and then after, if I take, whenever we require something, I will just write it down, take the picture.
Perfect. Thank you very much, sir.
No problem. Your major is civil engineering, right, John?
I'm an economics and business major.
Oh, economics. Oh, okay. Economics and business. Okay. Yeah, good major. Good major. Anyway, so let's start with this one. So xi plus 1 by 2. Xi is this one. Xi plus 1 is this one. I minus 1 by 4. I minus 4 is common. Right? Divided by 2. So let me take this one. So I minus 1 plus I. Okay. I minus 1 plus I, that is equal to 2I minus 1. So 2I minus 1 by 8. 2I minus 1 by 8 means 2I by 8. So that is I by 4 minus 1 by 8. Minus 1 by 8. So just simplification. Now my fx equal to 4x minus x square. I am looking for f of xi plus 1, xi plus 1 by 2. I am looking for this one. That means I am replacing my x throughout by xi plus 1 by 2. But xi plus 1 by 2 is I by 4 minus 1 by 8. So I am replacing this x by I by 4 minus 1 by 8 here and here. So I by 4 minus 1 by 8, I by 4 minus 1 by 8 and square. Don't forget this square. Simplify this one. 4 will get cancelled out. So I. 4 and 2, so 1 by 2. Minus sign as it is, a minus b whole square. Formula. A square minus 2ab plus b square. Formula. If you simplify this one, if you open the brackets, this bracket and this bracket, I minus 1 by 2 minus I square by 16, minus and minus will give you plus, I by 16, minus and plus is minus 1 over 64. If you simplify this one, here I have I and here John again, I and I by 16. Okay, let me write one more step. I plus I by 16, I plus I by 16, minus I square by 16, and these are constants, negative 1 by 2, negative 64. What is negative 1 by 2, negative 64? Or just, John, I'm asking you, give me the value 1 by 4 plus 1 over 64. Or all of you, please work on it. 1 by 2 plus 1 over 64. I want the value, please. Look at here. I'm asking you this thing. Actually, this is pre-calculus. 1 by 4, 1 by 2 plus 1 by 64. Give me this value.
It would be 33 by 64.
Yeah.
Why 33 by 64? Your LCM is 64. Your LCM is 64. Agree?
Yes, sir.
Sir.
Because LCM is 64, where is it? Yeah. Because LCM is 64, divide first term by 64. So 64, 1 by 2 plus 1 over 64. Agree?
Yes, sir.
Or you? So this will provide you 32. 32 plus 1 divided by 64, 33 by 64. Agree?
We said
Yes,
that,
sir.
sir.
Good. I will take the picture and send it to John. Okay. Okay. So I'm getting this expression. You can, of course, you can take over here. You can take LCM over here too, but that's fine. That's fine. You can count it. You can take the LCM or you can count it separately. So let me plug these values over here. All these numbers that is over here, because my formula says this one f of xi plus 1 by 2 by delta x. That is this number. Delta x is 1 by 4. First, whenever constant is there, just pull it out. Pull this out of the big summation sign. Big bracket, summation of I, summation of this, summation of this, summation of this. 1, 2, 3, 4. 1 over 16, constant, pull it out. 1 over 16, pull it out. 1 over 64, pull it out. 33, constant, pull it out. So here you're going to give 1. I, standard formation. N into n plus 1 by 2. N into n plus 1 by 2. N is 16. I square n into n plus 1 to n plus 1 by 6. And summation of 1. N is 16. So it is 16 over here. You can use your calculator or you can cancel the common things and use the calculator, and you are getting 10.687. See, previously I was getting 11. Am I right? For 4 strips.
Yes, sir.
Now I'm getting 10.687. My window is getting narrow, getting down. See, narrower and narrower. Look at over here. For here it is 10.625, 10.625 and 10.68. 10.6, very small window. Look at over here. Right? That means one thing is sure, your answer must be between 10.625 and 10.687. Agree?
Yes, sir.
Yep.
Rachel, are you getting me?
Yes, sir.
Good. Right, guys? So that's how we finish the first example using n equal to 16 strips and compare that one with our previous same example with n equal to 4 strips, 4 rectangles, and we found the differences. Agree?
Yes, sir.
Any questions so far? Any questions so far? Okay. Then after, now again, let me go back to the same example, approximate 0 to 4, 4x minus x square dx using right hand rule. Now see, I mentioned this thing, right hand rule. Forget about left hand and midpoint, because now specifically something is mentioned. With n equally spaced subintervals, n. Previously, first example, you were given n equal to 4. Then you were given n equal to 16. Now it says just work with general n. No numbers. Right? How to work with this one? I will let you know. I told you, n could be anything. N could be 2. N could be 20 and n could be 2 million. It could be anything. N is number of strips, number of partitions of your curvature bounded by some axis. Right? So work with this one, and then after, whenever you are working with general n, then after you can take n tends to infinity. N could be any infinite number, any infinite number. Right? That is the very, very best accurate answer. And very nearer to the exact answer, exact integration. Let's start with this one. 4x minus x square approximated, this is the approximation symbol. Summation of f of xi plus 1 delta x, because right hand side rule, it's xi plus 1. So first let me fix this one. Delta x is b minus a by n, 4 by n. Xi plus 1, a plus or x1 plus I delta x, right? 0, delta x is I by, I'm sorry, x1 plus I delta x. I as it is, and delta x is, delta x is 4 by n. So it is 4i by n. Agree? Delta x is 4i. General n. So n as it is. N as it is. Previously n was 4 and 16. Now it is general n. Okay? General n. So n as it is. Now my function was f4x minus x square. I am looking for xi plus 1. Xi plus 1. So x is replaced by xi plus 1 here and here. But xi plus 1 is 4i by n. So ultimately I'm replacing all my x's by 4i by n. So 4x is replaced by 4i by n. X is replaced by 4i by n square. These 4 4s are 16i by n. 4 square is 16i square by n square. So this is my xi plus 1. Just go back and plug it over here. And delta x is 4 by n. You fixed it. 4 by n. Now, this 4 by n is just constant, any real number. Positive real number, right? So let me just pull these constants out again. So 4 by n. 16 by n is a constant. Summation of 16i by n. 16 by n is constant, pull it out of summation I. 16 by n square, constant, summation I square. Same technique, same thing. Only thing is we are working with general n. That's it. And then after, summation of I is n into n plus 1 by 2, general formula, because it's now general n. Summation I square is n into 2n plus 1, n into n plus 1 to n plus 1 by 6. Simplify this one, this n and this n gets cancelled out. Here, now important, please mix your. I have to write down this thing just to explain to you. I am getting something like this. Look at here, guys. 16 divided by n and n into n plus 1 divided by 2 minus 16 by n square and n into n plus 1 to n plus 1 divided by 6. Outside is 4 by n. I don't bother. This outside 4 by n, I don't want to write. I don't want to disturb this term right now. Makes sense. Makes sense.
Yes, sir.
Yes, sir.
Yes,
Right.
sir.
Don't look at here. I am just working on this one, this arrow. Okay. Good. Now I can cancel this n and this n. So let me cancel this n and n. This is 16 and 2, so it is 8. So it is 8 here. What is left out? Simply n plus 1. Agree? So 8 times n plus 1 minus. Here it is 16 and here it is 6. So I can cancel this one too. If you don't want to cancel, that's fine. So let me write like this: 16 divided by n square times 6. And here it is n plus 1, 2n plus 1, 3 and 8. Shall I write like this? Look at here, guys. All of you agree with me? All of you agree with me?
Yes, sir.
Right? Now what I'm going to do, look at here, guys. I want to take my n out. You have to. How? Look at here. I just put the arrows. Can you see all these, my 3 arrows?
Yes, sir.
Take this n out. Take n out from here. Take n out from here. How can you take it out? My last expression, see here, it is actually n plus 1, simply n plus 1 over here. N is the first step. And I want to take n out. I don't have any n over here. Divide and multiply. Look at here, John. Divide and multiplied by n here. So whenever you have, let me write separately. Suppose n plus 1. Look at here. Suppose n plus 1. And I want to take my n out. I'm going to do something like this. N plus n and n. Divide and multiplied by n. Agree?
Yes, sir.
Now I can take n out from the numerator. So what is left out? 1 over 1 over n. Agree? Look at here.
We can't see it.
Now, this one.
Still can't see.
You can't see
Now we can see it, sir.
Now we can.
this one. Right? So if you take n out, what is left out inside the bracket? 1 plus 1 over n. Agree?
Yes, sir.
Yes, sir.
So that's what we are going to do here. 8 n out, 1 plus 1 over n for the first step. 8 n out, 1 plus 1 over n. First step. Look at here's cursor. 16 n square. I am taking again my n out. So 1 n is there. 1 more n is coming from this bracket. So it will be n square here. Here it is 1 plus 1 over n. Agree? Here, if you take this n out, look at my cursor, guys. If you take this n out, what is left out? 2 plus divide and multiplied by n. So 2 plus 1 over n. 2 plus 1 over n. So 1 n is from here, 1 n from here, 1 n already outside, so it is n cube. So total n cube. So I'm going to get minus 8 over n square n cube, 1 plus 1 over n, 2 plus 1 over n. Can you see this last expression here? Agree?
Yes, sir.
right? And that is exactly same as whatever I wrote it down here. Just simplify this one. You are going to get, now outside I had, look at here, outside I had 4 by n. 4 by n. Let me take this 4 by n inside here and here, multiply. So 4 by n, 4 by n, 4 and n. So I multiplied here by 4 by n. I multiplied here by 4 by n here. 4 by n and 4 and n here. Why? Because if I'm doing this thing, see here it is. Here I'm getting n square and this n means n cube. And this n cube and n cube will get cancelled out. Here it is n here and here I have one more n, so this n and n will get cancelled out. So I'm just left out with 8 4s are 32, 1 plus 1 by n. Right? N cube will get cancelled out. 16 4s are 64, 64, 1 plus 1 by n, 2 plus 1 by n divided by 6. Divided by 6. If you multiply, if you cancel this one, look at here. This 6, 3 2s are 6 and 32 2s are 64. So 32 divided by 3. 32 divided by 3. So this is my expression. This is my final expression. But this summation is nothing but, now what I'm going to do, I told you, because we are working with general n, just pass the limit. Limit as n tends to infinity. If you pass the limit as n tends to infinity, see, limit over here, 1 over infinity is 0. Agree? 1 over infinity always 0. Please keep in mind this thing. 1 over infinity is always 0. So this will be 0. This is 0 means what is left out? 32 times 1 is 32. Agree? So 32. Here 1 over infinity 0. 1 over infinity 0. This is 0. This is 0. 2 plus 0, 1 plus 0, 1. 2 plus 0, 2. 1 multiplied by 2 is 2. So 2 is there. 32 multiplied by 2 is 64. 32 multiplied by 2 is 64. Divided by 3. Divided by 3. Simplify this one. 32 out. 1 minus 2 by 3. You are getting 32 by 3. Your exact answer is 6.66666. 6.6. Left hand rule I got for 16 strips. I got 6.625. 10.625. Right hand rule I got 10.625. Midpoint rule I got 10.628, something like that. But in between this figure, these numbers are in between those two numbers because I increased my strips now, number of rectangles. And that's why I'm getting this one. So your homework is left hand rule. I am getting 10.6 by my right hand rule. This is my homework. I will ask you tomorrow. So tomorrow, please finish this one. Homework is left hand rule. For the same example, same n. Whenever you are working with general n, always keep in mind this thing that finally go for n tends to infinity. That will provide you the answer. Okay? That will provide the answer. Okay. Some of the examples from your practice test to get here. I solved some of the examples. 3i minus 1, -1 to 3. A is -1, B is 3. Midpoint rule, delta x, b minus a by n. 4 by n. Xi is a plus I minus 1 delta x. So I'm getting xi equal to this one. Xi plus 1, a plus I delta x, a or x1, whatever you want to say. So I'm getting this one. Midpoint means xi plus 1 by 2. Add these two, divide by 2, simplify, you are going to get this one. My fx is 3x minus 1. 3x minus 1. F of xi plus 1 by 2 means I have to replace this 3 by this xi plus 1 by 2 means this factor. So 3 is replaced by, 3 and this x is replaced by this number. X is replaced by this number. 3, 4i by n, minus 2 by n, minus 1, and this minus 1. Open this bracket, simplify, you're going to get this one. Once you fix your this one, integration -1 to 3, 3x minus 1 dx is approximated by this formula. This is only you figure it out, these numbers. Just plug it over here inside the summation sign. Delta x is, what was delta x? We fixed, we found delta x is 4 by n. So 4 by n is just out. Summation of 12i by n. So 12 by n is out, and summation I minus 6 by n is out, summation 1 minus 4 out, summation 1. And if you simplify this one, you will get this one. Take this n out. Once you take this n out, this n and n square will get cancelled out. This n square and this will get cancelled out. And you are getting this one. Finally, pass the limit as n tends to infinity, and you are getting 8 as the answer. This is the example from your practice test assignment. I'm just helping you because you should not feel that I left every example for you. So some of the examples in all the assignments, I'm going to solve at least 50% of the assignment examples. Okay. Properties of definite integral. Now, before we start with the properties, I think it's already almost 8:50. You need a break. We are learning since 1 hour 15 minutes.
Yes, sir.
Okay, so I can give you 5 minutes break, and then after we can start with the properties of definite integral. Okay, break of 5 minutes. Okay, use your restroom if you want, or you can go for what? John?
Yes, sir.
Send email to me.
Yes, sir.
And I can give you my phone number. Then you can text to me. Or send your phone number to me. Or no, you. Okay, send your phone number to me. That's fine.
Yes, sir.
Sir, I had a question as well.
Yes.
Could you send me the video recording of today, or perhaps put it on Canvas so that I can review it when going over the lesson?
Video recording, why you need the video recording? Is it okay? Is it okay? I don't know, but is it possible that I can put this video recording on YouTube?
That would work as well. I know for Calculus
No, I
1.
don't know.
our
No, I'm
teacher-
asking you actually, I don't know how to, put the videos, all this, because Zoom has
Oh,
its own software. So I tried yesterday, but it doesn't allow me. It did not allow me to put my videos, Zoom videos. I can take the pictures and take the videos in my cell phone, and I can download and put it over there on YouTube. But Zoom,
okay.
somehow it doesn't. I think I need to fix. I have to learn that thing. I don't know. Maybe I'm missing something. I don't know. But I will do that thing.
Okay.
Okay. I will try. I can't promise you, but I will try. Okay.
Okay. Thank you,
I
sir.
don't want to fill up all my space in Canvas. So I will put on YouTube. Probably it will be helpful to you. I'm trying. Trust me.
I understand.
And if you find something, let me do one thing. What's your name? First name I forgot.
Charles and Sheriff.
Charles. Yeah. So Charles, do one thing. Just try to figure it out how to put the Zoom video on YouTube. Can you
Okay.
figure out this thing and let me know? Just teach me. Okay.
Yes, sir. My programming teacher did it for our class, so I'll ask him. how
Okay.
he did
Zoom
it.
video on YouTube.
Yes, sir. Mhm.
Okay, so nice of you. Please try to ask him and just teach me so we can do this thing just in our meeting, right?
Okay.
Because I have my video recordings of yesterday class and today's class. I want to put everything on YouTube so that you guys can use this one whenever you want it.
Okay. Thank you, sir.
Multiple times, yeah. If once it is on YouTube, you can use it multiple times, and there is space bar or some restriction. Right? No space restrictions or like this in YouTube. So I think that is the best idea. So yeah, definitely do that thing. Yeah.
All right. Thank you, sir.
No problem. John. John,
Yes, sir.
did you get the picture?
Let me check my
No,
phone.
no. It's going on. So probably just wait for a couple seconds.
Yes, sir.
Yeah. So I think, yeah, this sounds good. So I got your number and I already sent it to you, this picture. And you please
Perfect.
forward this one to all guys, okay?
Yes, sir.
It takes some time. Always it takes about,
Of course, of course.
yeah. And I've again, what is this? Scarfka? What you said your first name? Scheerff.
His name's Charles.
Yes, sir. Charles.
Charles. Okay, I'm sorry. Charles. Yeah, Veer, but you were not here yesterday, right?
No, I was here, sir.
Oh, you were there? I'm sorry.
Yes, sir. No problem.
I'm sorry, I couldn't pay attention. I'm sorry. Where are you from?
Northern Virginia.
Northern Virginia, DC?
Yes, sir.
Means where? Fairfax?
Loudon, actually.
Say
Right
again?
next to Fairfax. Loudon
Oh,
County.
okay. Oh, Loudon County. Okay, I know it. That's good. And what's your major?
Electrical and computer engineering, sir.
Wow, good. How long you been over here?
I've lived in the States my whole life.
Oh, okay. So you born and brought up over here?
Yes, sir.
And your parents, they are from India, right?
Yes, sir.
Which part? Gujarat?
Gujarat, yeah.
Yeah, I know. Which part? Baroda? Ahmedabad?
Ahmedabad, yeah.
Ahmedabad or near Ahmedabad? Mostly a weird, but okay, yeah. Okay, Ahmedabad. Where? Where in Ahmedabad? Navrangpura?
I couldn't tell you, sir.
No, you don't know. That's fine. What your dad is doing?
He doesn't live with us anymore.
Say again?
He doesn't live with us anymore.
Oh, I'm sorry. I'm sorry.
It's all good.
Okay. I didn't see you. How long you are here at VMI? This is your second year?
First year, sir.
Oh, this is your first year. Okay. Oh, yeah, first year. So you finished first year, right? Now you are going to second year, right?
Yes, sir.
Oh, I didn't see you. Good. We have one student over here from New Jersey, I think Kisan Patel. You don't know? Yeah, he left. He got his admission, I think, in Rutgers, just side to his home. So he stayed over here for 2 or 3 years, I think. So and last year he finished over there. He completed over there. Okay, guys, shall we continue? It's already 6 minutes. Shall we continue?
Sir. Yes, sir.
Good. Nick Ton, how are you?
Fine. How about you, sir?
I'm okay. Okay, guys. Good. Good to see you. So let's continue. Your most difficult part is over of this chapter. Yes, most difficult part is over. This summation formulation, that is over. Just work on these problems. I don't know I have given you any summation problems or not, but that's fine. I will give you examples probably in today's class. Yeah, some of the examples, some of the homework assignments, because in your assignment, these problems are not included. I think so. So I'm going to give you some problems separately, probably. Yes. Okay. Okay. And that's the end. Okay. So most likely you guys are going to take your exam on Monday. Monday is Memorial Day, so we don't have any class, right? So that's a good, yeah, that's good part for you too. I mean to say, if I finish your syllabus by Friday, syllabus for the first exam by Friday, then you can have big interval, 3 days of gap, right, to prepare yourself for the exam. So Saturday, Sunday, and Monday and Tuesday, you are taking your exam. Sounds good?
Yes, sir.
So there's a plan right now. If some change is there, I will let you know.
So the exam is on Tuesday?
Exam on Tuesday, first test. Yeah, because actually, it was on Friday, actually, but this time we started our summer session on Tuesday. So that's why, because we are missing one day. That's the reason it's on Tuesday. Anyway, that's fine. So Tuesday is your first test, Tuesday morning, 7:30. Okay.
And is that just on chapter 5?
Just chapter 5. We have 4 exams. One is chapter 5, chapter 6, chapter 7, and chapter 8. That's it. We are done. Okay, 4 exams each chapter.
Excuse me, sir.
Yes.
When will the practice exam be uploaded?
With the exam and on the day of the exam. So I want your practice test, means your homework with your exam. I'm going to submit the assignment on the canvas. Once I submit the assignment, that means it will allow you to submit. I mean, say, once I put the assignment on put your exam on the assignment, then after it will allow you to submit your homework and resubmit your exam. Right? So
Okay.
yeah, but don't wait till the exam day. I would do like this. I would just try to go through all the examples with our class.
Okay. Thank you, sir.
Otherwise, at the last moment, it will be probably difficult for you guys to go through all the assignments and everything. So please do this thing. Just work simultaneously. Work with me. Okay, guys. Yeah, so we talk about this thing, and now, all these things. Now, let me just check this part too. If I have your find the antiderivative. No, it's just antiderivative. This is article 5.4. So I have not included 5.3, but I will give you 5.3 separately. Don't worry. 5.4, yes. I think 5.3 is missing, but anyway, I will try to figure it out. So 5.3, okay, it's not here. It's not here. I have to create some examples for you. I'll do it.
So, sir, we're doing these problems that you have up on the board, right? And then we're turning that in on test day, right?
Correct. These problems means the assignment, practice test problems. These are just the classwork. You can,
yes, sir, the blank
but
problem.
this is not a part of the homework. Part of the homework is only this one. Look at over here. Whatever assignments I'm going to provide you, this like this, practice test examples. There's the assignment. That's a part of the homework. Okay. I'm sorry, I have not given so far the section 5.3, means your whatever we are doing right now. Summation formula, example based on this summation formula, summation method, but I will give it to you very soon.
So is there a specific time we have to take the test?
Yes, 7:30 to 9:30. I mean, say, yeah, that's a good question. See, usually our test, that is for that, I can't give you more than 1 hour for the test. Because if we are teaching on Monday, Wednesday, Friday schedule, in that case, your test period is 50 minutes. If we are teaching on Tuesday and Thursday, your test period is, I would say, 1 hour, 15 minutes. But actual test time in common, it is 1 hour. So Tuesday, we can do one thing. Tuesday, we can start our test at 8 and you can stop at 9. So it would be a little bit relief to John because he's in Colorado. Right, so it means we can start our exam at 6.
Ooh.
6 on Colorado, and here it is 8. Right, or we can do one thing. We can start our exam at 7:30 to 8:30, and after 8:30 we will continue with our teaching. But I just leave it to you. If you think that after the test probably you will be tired, and you don't have any mood to do anything more, I don't mind, that's fine. But if you want me to go through the syllabus after the test, that sounds good to me too.
8 to 9 sounds perfect.
Decide yourself and let me know by
sounds
Friday.
great.
Say again?
Sounds good, sir.
Which one?
8 to 9, sir. 8 to 9.
8 to
8 to
9.
9. I knew that. That's fine. 8 to 9. Okay. So, yeah. So, Tuesday, we are going to meet at 8 and we'll start the exam, right? Okay, guys. And I will try my best to post, to give you the examples, some of the examples based on this article 5.3. I don't know how can I miss that assignment over here. I think my pages are messed up. Anyway, I'll fix that thing as soon as possible. Okay, so now let's continue with this one, properties of definite integral. See, integration a to a. A to a means we are not given any region, it's just one line. A to a, fx dx. So there is no area, means it is 0. Whenever lower and upper range are same, integration is 0. Integration of b to a. If you want to flip the range, lower and upper range, lower limit, upper limit, like this, a to b, you have to use the negative sign. Integration a to b fx dx, a to b. And if you want to divide in two parts, a to c and c to b, you can always do it whenever your function is continuous. Whenever your function is continuous. Integration a to b k times fx, k is constant. Again, the same thing, pull it out. Integration a to b fx dx, plus and minus. Integration is linear in addition, and that's why you can write separate integrals for both of these functions. Integration of fx plus integration of gx. Integration of fx minus integration of gx. But you cannot write for product, no. We are going to learn one rule for the product of two functions, and it's integration, just like your derivative. If you have division, you cannot write like this, because integration, just like your derivative, because derivative and antiderivative, they are just the reverse process. So whatever the rules are not applicable for derivative, the same rules are not applicable for integration too. You know that linearity rule for multiplication and division is not good, not applied for derivative. So same for antiderivative. Make sense? Make sense?
Yes, sir.
Yes, sir.
Sir.
Girls, yeah, good. Good. And one more thing, negative a to a fx dx. If your fx is an even function, suppose I give you integration x square dx. X square is an even function, right? Even function means, do you know the definition of even function? Oh my gosh, not fair. Even function means
minus f of x equals
f of negative x equal to f of x. Means if you replace your x by negative x, your answer is same. You are not changing your function. As per example, suppose I give you f of x square, y equal to x square, or fx equal to x square, I would say. Fx equal to x square. And if I replace by c, fx equal to x square like this. And if I replace x by negative x, so x by negative x, so that is equal to negative of x square. Agree? But negative x square is x square. Because
Yes, sir.
square is 1, so it is x square. Means I'm getting my function back. Agree? Look at here. Yes or no?
I don't think we can
Yes,
see.
sir.
Oh, sorry, my bad.
That's good right there. Thank you.
Mm-hmm.
looks good.
So that is your x square. Other way around, geometrically you can see even function means if your figure is symmetrical about the y-axis. So fx equal to x square, you can see my figure is symmetric about the y-axis. Right? So that is called the even function. So parabola is the even function. My figure is symmetric about the y-axis. Or function. when f of negative x equal to negative of fx. This is called all function for all x. Example, fx equal to x cube. Say f of negative x equal to negative of x and cube. So negative 1 cube and x cube, that is equal to negative of x cube, and that is equal to negative of fx. Like this. Okay. And the figure is geometrically x cube figure is like this. That means your figure is symmetric in the opposite quadrant. That is called the OR function. So opposite quadrant, symmetric about opposite quadrants. Right? You can say first and third quadrant figure is same. If you flip the page, the first quadrant is set up exactly on the third quadrant. If you turn the page like this, if you do like this, that is your odd function, first and like this. But if you do like this, my page is like this, if you do like this, symmetric about y-axis. This is my y-axis. I'm just flipping like this. So whatever the portion I have on my other side of y-axis, it would be completely coincided with my other part, a positive side of the y-axis. Right? That's what I mean by the symmetricity, symmetric. I can send this picture also to John, and John will send everything to you guys. You need this thing, right? Yes or no?
Yes, sir.
Thank you.
No problem. Okay. So whenever your function is an even function at that time, you can flip like this. If you flip like this, that means again your range starts with 0. So 0 to A, because other side, first part and second part. First part is completely overlap over here. That means it is 2 times 0 to A fx dx. Fx is even. And here, whatever the area, look at over here. See, area above the x-axis and area below the x-axis will get cancelled out because the same numbers are there. Same area is there above x-axis, same area is there below x-axis. Here it is positive, here it is negative, it is 0. Agree? And that's why integration negative a to a fx ds, if your function is an even function, it is 2 times. If it is odd function, it is 0. It is simply 0. If it is odd function, it is simply 0. Right? So these are the properties. Then after, let's go through last one. This is your function f. Now we are finding the area between two curves. This is your function f. This is your function g. I am looking for the area between two curves. So what I'm going to do, you know the area under the curve. Function f, area that is bounded by x-axis, x equal to a and x equal to b, means this one. You know the area of g, area under the curve g. Curve g, x equal to a, x equal to b, and x-axis. So this is the area. This whole is the area. So if you are looking for in between, area between two curves f and g, or g and f, that means I have to consider what? The one thing is sure, area covered or area under the curve F is less than the area under the curve G, right? Because this is a positive axis and this is the smaller region. So area means integration of fx dx is less than integration of gx dx. Am I right?
Yes, sir.
X is less than gx. Because my fx is less than gx, that means your integration area is also, this is a smaller area, this is the larger area. Under the same, under the curve, bounded by x-axis and same x equal to a and b. If function is integrable and non-negative on a to b, then integration of fx is always positive, greater than or equal to 0. If f is integrable and non-negative on the given interval. Okay, sketch the region whose area is given by the definite integral and use geometric formula to evaluate it. Okay, again the same thing whatever we did yesterday. See, 2x plus 5. 2x plus 5 is the line, right? It's the line. If you take different values of x, you're going to get different values of y. Suppose x equal to 0, y equal to 5. So x equal to 0, y equal to 5. That means this is the intersection point on y-axis. X equal to suppose 0. Then let me take x equal to 2. X equal to 2, 2 to the 4 plus 5 is 9. So 2, it is 9. So 2 and 9. So this is my area. This is my area. Right? Now, this is a kind of, what is this? It's not parallelogram. But the formula for this one is 1 by 2 h times height and b1 plus b2. This is my b1. It is 5. My b2 is 9. And this h is 0 to 2. That is 2. So just plug the values and you can find the area. You can find the area. So you can just draw the picture and trying to figure it out the area like this too. But that is not possible always. Here it is 9 minus x square. If I take y equal to 9 minus x square, so y square, if I square both the sides, y square equal to 9 minus x square. So x square plus y square equal to 9. It's a circle with center 0 and radius 3. If I have this thing, but I have just given square root of 9 minus x square means upper part, semicircle, upper semicircle, just this part, not the full circle. So upper semicircle. Area of the circle we know that is 1 by 2 pi r square. So 1 by 2 constant, pi constant, r is the radius is 3, so 3 square. So it is 9 pi by 2. 9 pi by 2. Later on we are going to use the integration formula. You know the integration, term by term integration, right? If I want to find this one, look at here again. If I want to find this one, suppose integration 0 to 2, 2x plus 5 dx. So integration 0 to 2. So 2x is x square by 2 and 5x. And range is 0. This is called definite integral. I'm teaching you right now definite integral 2. So my first example, this one, that can be written in this form. Agree?
Yes, sir.
Right? And range is 0 to 2. Because it is definite integral, there is no c. I told you yesterday. Now replace your upper limit. Replace your x by upper limit 2 and then replace your x, all x's by lower limit 0 in between negative sign. That is called second fundamental theorem of calculus. So that is equal to 2 will get cancelled out. Here it is 2 square plus 5 times 2 minus 0 square plus 5 times 0. So 4 plus 10 minus 0, it is 14. See, I'm getting the same answer by integration. And whatever I used over here, I replaced all my x's by upper limit, all my x's by lower limit in between negative sign. That is called the second fundamental theorem of calculus. It says something like this: integration fx dx a to b, that is equal to fx a to b, that is equal to fb minus fa. If capital F is the integration of small x. If capital X is the integration of small x, a to b fx dx is fx a to b FB minus FA, upper limit minus lower limit. That is called second fundamental theorem of calculus. Second fundamental theorem of calculus. Second fundamental theorem of calculus. Okay, guys. So whatever we did, thanks to Riemann, he just tried to figure it out, just simple calculation like this for the integration. And we all are getting very simple things. Now, I have a couple formulas. You have to keep in mind this thing, these formulas and mean value theorem. I think it is better if we can continue this thing tomorrow. Right? I don't want to give you everything at a time. Make sense?
Sir.
Yes, sir.
Okay, guys. So thank you so much. Work hard. Take the problems from the book for article 5.2 at least. Summation formula, midpoint rule. Then right hand limit, left hand limit, right? Midpoint limit. So just take the 4 examples from the book and try to solve it. I will try to figure it out, some other examples for you too very soon.